Hello, my name is Jared Terabakia. This is my arc length project for AP Calculus AB. I guess we're just going to get right into it. So, what path did I choose? My path was my town high school's track. This track, a couple blocks away from my house. I mean, within walking distance, takes 5 minutes to get there. It's a field that I've played on, or the tracks are on the field, and it's a field that I've played on for baseball, football. I practices games on this field, and I was interested in it because I knew it wasn't a normal size track. However, it's a little weird because like I hear different things. Like, is it 5 laps to run a mile? Is it 6 laps to run a mile? I was unsure of that. Anyway, so I wanted to see I wanted to see how it differentiates from an actual track. To see how many laps it would take to run a mile. Anyway, so I used Google Maps measuring tool to get the following measurements. You can see the dimensions. I took the length of the field, 240 feet on each side of the track actually, and then the width of the track, 306 feet. These are all taken using the Google measurement tool. And then that was just the distance from the arc length until the end of the arc basically. All right, so as I was saying, like the length of a lap would be the length of the track times 2 plus the length of the parabola times 2. Now, the numbers came out to lap length equals 240 times 2, which is 240C in the picture. To be two of those, basically finding the perimeter to find the length of the lap. And then the length of the parabola, we don't know that length, so we're going to use the integral equation to find the length of the arc. Anyway, basically, to do this, I used I graphed the points. I had as you could see, I had 0, 0 in my origin, right there, and basically I just calculated the side to the other. It's 306 to the other side of the field, and then we had a little point there, 153, y coordinate 78. That was like the midpoint of the arc. I'm just checking which time I have. All right. So the arc length formula is L equals the integral from A to B of square root of 1 plus dy over dx squared. So basically I had to use this equation to find what the length of the parabola was. To do this, took L equals, I skipped one. Anyway, all that stuff still remains, but I'm just going to talk about this. So points for the quadratic regression calculation. This was before what I was just talking about. Basically, I plugged in my points on this site, and I got this picture right here. You can see that was like the graph, and they had like the coefficient numbers, all that. But anyway, it gave us this formula for the quadratic regression. As you can see, f of x equals that number, and then we also had to find I needed the derivative of that to plug it into the equation later to find the arc length. So then this is the arc length formula, as I was just saying, the parabola length. So I took the integral from 0 to 306 of the square root of 1 plus the derivative of the function of the quadratic regression function that we found earlier. Basically, sorry. So that was the equation again. That was just a picture of actually calculating the equation, and I found that the arc length was 352.543. So basically, what I went back into, I knew the lap length was 240. I mean, the length of that dimension was 240. So times 2, and then plus the 2 arcs, which were equal to 352 each side. And I found a total of 1,185 feet. About. So conclusion, my town's high school track is a total of 1,185 feet based on the measurements done. How's it going? I'm just presenting. So how many laps does it take to run a mile on the track is what I'm curious about. So with the total feet in a lap, in a mile, divided that by how many feet were in the lap at my town high school, Cliffside Park High School, and got 4.5 laps to run a mile. And that's pretty much it. Thank you.